Okie dokie. So this is the pixel badge. Yeah, I just wanted to make a video kind of talking about it a little bit because I keep posting little snippets about it online, and I just kind of want to go through everything and talk it out. So here's a couple boards that I've already assembled. I guess, yeah, this one this is the most complete one, really. Obviously you can see the bond wires on it. I'm going to try zooming in. Whoa, there we go. Forgive me, my tripod's really wobbly, so every time I touch the camera to change something, it's going to wobble a bit. Anyways, yeah, so there's a close-up view of the pixel badge. It's assembled. It's got the bond wires complete. The bond wires are like kind of the striking feature that I feel like everybody is really impressed by. And yeah, I don't know, it was something I was looking forward to executing after seeing some sculptures by Mohit Boidi. I'm unsure the pronunciation of his name, but his little like freeform circuit sculptures are really interesting, very beautiful, and a big inspiration. But yeah, I mean, back in the day, a couple months ago, I made this shitty add-on for DEF CON, and it's like, I mean, this was my first idea when I started making a circuit board. I was like, oh, I'm going to emulate a NeoPixel because I just thought it was like a funny, kind of cheeky idea, and yeah, just went for it. And it turned out pretty well. Like I was really impressed by it. But like one thing while I was designing it like bothered me that the bond wires were the silver color while the copper pads were also silver because I mean, in real life with a real pixel or with a real WS2812, the pads are silver, but the little bond wires are gold. And just aesthetically, that kind of bothered me. And I guess, like, I mean, a ton of this stuff with the badges and with making circuit boards, for me, at least so far, it's been highly aesthetics driven, I guess. Yeah, I don't know. I don't have a background in like electrical engineering or anything related to hardware really, but like I have done a lot of design in Photoshop for like making t-shirts and layouts for various kinds of artwork, and so like I have a handle on manipulating images digitally, but yeah, I'm trying to apply it towards this circuit board art and this whole badge life thing, and I don't know, it's been a fun adventure, but that's like my initial approach. It's always from the art. I don't really think about things from the circuit standpoint or like electrically first, and maybe I should. I'm definitely learning to, because, I mean, the art can't be the overruling factor in everything. But anyways, back to what we're talking about here. I guess the shitty add-on that I made last year, I wanted to make the different colors between the silver and gold like I was talking about earlier. And yeah, so after seeing the freeform circuit sculptures by Mohit Boidi, I was like, okay, I gotta try the brass rods. And I can grab some. Here's the packaging for them. It's some K&S 1/16 round brass tube. They make rod as well as tube, which isn't hollow, but this stuff is hollow. Yeah, and at least what I ordered came in 1 foot lengths, 12 inches. And yeah, and then I cut it down from there and make these small pieces that go down into the circuit board. Yeah, they make really good looking bond wires. Speaking of, I mean, I have this microscope set up. Here, let's try and check it out. There it is. Forgive me while I learn how to use OBS and how to do this streaming thing. I'm just manipulating some stuff here. Oh, I guess it was fine the entire time. Anyways, sorry. I don't know what I'm doing. Yeah, there you go. There's a really close-up look at a WS2812S. That's the 6-pin version. I got this one specifically because that's like the design that I've been going after this whole time. I actually had a bit of confusion in between the different versions of like this style of LED. There's just like a couple different versions, and they have different letters as suffixes, and they're just slightly different from one another. And again, yeah, there's also some differences with the model numbers, like WS2811 versus 12, 12B, 12S, and then like I was looking at the World Semi page, and there's actually a bunch more that I'd never even heard of. So yeah, there's a whole bunch of different part numbers, and I've been trying to figure out what 2812 means. I asked on Twitter. Some people said that it was just like the 2,812th part they made. I know that the IC driver that kind of preceded this was the 2811, but yeah, I'm curious if there's any kind of technical reason behind the name. Anyways. So check it out. That's like a tiny little NeoPixel. Well, there's my tweezers. You can see the gold bond wires versus the silver down there. And that's like, there you go. That's the inspiration for this design. So switching back over to the overhead camera. Yeah, there you go. Or maybe I'll just switch a couple times. See? Real pixel, my badges. Real pixel, my badges. It's I don't know. It's a cool design. So let's turn one of these things on. Here, let me steal the battery out of this guy. And I plug him into here. And we'll turn it on. So right now, here, let me zoom out. So right now, I guess I should explain. You can kind of see on the backside here, there's a switch right here, and it says pixel data, external versus internal. And right off, that was one of the features that I wanted on this badge. I wanted to be able to generate pixel data internally on the badge and then be able to output it to other badges so that I could chain them together just like you do on like a big strip of pixels. But that meant that also all of them had to have an input, obviously, so that they could take in data. And I wasn't really sure how to handle that, but I decided to just put a switch in, and it just physically switches the data line between this port or the pin that I have programmed to spit out the NeoPixel data from the ESP32. So right now it's on external data, and that means that it's taking in data from this port, which I have this little board plugged in right now. And that board is something I got of AliExpress. And it, here's one in its packaging still. Let me open it up. Basically, it's just like a wireless control board for this type of WS2812 pixel. Here you can see model number, I guess. LED 2017 RF lock. Oh, the LED Dream Color controller. It's really cool. And I guess you can take in 5 to 24 volts, and then it outputs to, I think it does a couple different kinds of strip, not just WS2812s, but I'm not positive, and that's what I've been using it with, and I know it works for at least that. But anyways, I tore that open to see what was going on inside, because initially, actually, I wanted to try and take the electronics from this and put it on the badge, and I still might attempt to figure that out. But for now, this is what I'm doing. But I took it apart. I soldered up some, I have a bunch of these jumper cables that are JST PH connectors. I'm learning more about researching the proper types of parts for a lot of different things. Because as an outsider to electronics and circuit design and electrical engineering and engineering in general, I don't have the attention to detail and just like, I don't know, essentially the attention to detail to like really pay attention to these things and make sure that everything is exactly perfect, like from the get-go. And it's something that I'm working on, but not quite there yet. Anyhow, yeah, so I saw a lot of pixel strip or NeoPixel stuff from Adafruit come with this kind of connector. It's a JST, I already forgot, SM, I think I want to say. And that's kind of what I was anticipating to put on the backside of these badges. But when I looked around for components on DigiKey and other websites, I couldn't find a surface mount JST SM right angle connector like this one that I found in the PH style. Yeah, so I went with the PH, obviously, because it was what was available. And I don't know, it's great. It's just different from this, so it's not what I'm used to, but I ordered a pack of these guys, and now I'm good to go. So back to this control board. Yeah, it's like, I mean, it's paired with this remote control, and I had to do that after when I pulled it out of the package. I plugged it in, it automatically started spitting out this data, and you have to hold the this kind of padlock button, and if you hold it for 3 seconds, it should flash 3 times. Oh, huh, I don't know if, oh, yeah, I guess we're still paired. I just repaired with it. Yeah, so just basic features of, I mean, this board, you can control the RGB, the white, the brightness of the board, and then it's got a whole mess of animations built into it. So if I put it on auto, it just starts kind of scrolling through everything, I think, and you can adjust the speed of the animation and then scroll through each of the different animations that it has manually by pressing the button. And that's pretty cool. Like, I mean, it has nothing to do with my project, but it's awesome that I was able to like instantly build that into my project because of the way that I designed the circuit to accept external data, or data, not Dana. Yeah, so that's really neat. But I'll just, oh, and to like kind of demonstrate, there is a program running internally on the ESP32 on the badge itself, and if I just flip that switch right here, bink, now that's the internal program. And I was really unsure about this at first. I didn't know if, well, and I guess I still don't know if this is going to cause any problems long term, just kind of switching right between the data line like that. I did follow the best practices in the Adafruit NeoPixel Uber guide that they have online, the big PDF with like everything about these, and it just says to put a resistor on the line. I think it says between a 300 and 500 ohm resistor on the data input line for any of your NeoPixels, and so that's what I did. I think I put a 330 ohm resistor, and I put that on the input side of this switch, so no matter which way the switch is switched, it's like either data set is being run through that that resistor that I mentioned. And then additionally, I think I put another one on the output so that no matter what is plugging into this badge, it'll have a 330 ohm resistor on the data line as well. I don't know if that's the correct thing to do, but that's what I did. Oh, I guess I could do this. I don't think that this is like a good thing to do, but I've also been trying to break stuff a little bit. So I've been hot plugging NeoPixels just to try it. Here we go. Check it out. Turned right on. This is just, I mean, you can see the end sticking out. It's a normal WS2812 NeoPixel strip from Adafruit, but I have it in this cool diffuser, so it looks kind of neat. But yeah, that's being run off of the external wireless board that I got from AliExpress, and then again, here I'll switch over to the internal data, and I guess everything on the strip is going to just hang where it was because it's not getting any new data, but internally only the 3 pixels on the badge are being driven. And this is actually getting to one of the very first I don't want to call it mistakes that I made, but this is something that I'm going to change in the next version of the board. I'm going to separate, so right now, anything on the output side plugged in through this port, it's just considered the next pixel in line after the 3 that I have on board. And I'm going to end up making it to where these 3 are controlled separately as their own string of pixels, so that then I can, like, no matter what, I can independently control the 3 on board plus anything that's plugged in externally, because right now it's all in one big chain. And like the thing that's causing me the most grief with that actually is I don't know how to dynamically change the number of pixels that it's programmed to handle, because as far as I know, and everything that I've always done with like an Arduino and a NeoPixel, you just define the number of LEDs that you have in a string. And in this situation, I'm not going to know how many are plugged in. So my first thought after this initial board that I made is to separate the 2, so I can always have some known thing happening on the 3 pixels that are on board, and then kind of adding code to handle whatever is going on for the external ones. I'm still not 100% sure. I haven't thought it all the way through, but that's, I don't know, that's my thought for now. Yeah, so I'm actually gonna, here, I'll turn this off, I'm gonna strip it down, unplug all the bonus goodies, and just talk about what it does by itself, because I kind of started off showing things that have nothing to do with the badge. But just for those that are curious about this external board that I have plugged in and what this extra wire is for, that's what's supplying the power to this board. The power pin on this input I didn't connect to anything because I didn't want to run the risk of inputting voltage that is different from what's going on the badge, at least through this port, because I personally don't know how to handle it. This badge is running off of 3.3 volts, and I know that that's not really within spec with the NeoPixels, but I'm like, I don't know, a lot of people say, and I've read it online a bunch and done it personally myself, I've run them off of 3.3 volts and they seem to work okay for the most part. And yeah, so because of that, I didn't, and because of the way I want this all to chain together, I didn't want to, I didn't want to have somebody trying to plug in a 5-volt strip that's already got power in it into the badge and have it all fry or do something bad. So yeah, this pin is just not connected to anything as far as the power goes. And because of that, I just jumped over and got power off the 3.3 volt line. And it's interesting because this badge, it actually says right on the back, and it's printed on the sheathing that I ripped off, that it's 5 volts to 24 volts. But just like the NeoPixels, this board seems to be working okay off of 3.3 volts. Yeah, so that's like this whole mod thing, and I'm pretty sure if I don't end up making this a if I don't end up transferring the electronics from this board to my actual badge, to my PCB, I think I might build a handful of these little mod kits in case somebody wants to use a remote with it, just because it's kind of cool. Like, I plan on having one set on my desk at work, and it's kind of like a fun thing to be able to, I don't know, remote control it, I guess. And plus I bought a bunch of packs, or not a bunch, I think I bought a dozen of these controllers, so I don't know, that's not too many, and a fair amount that I can tear apart and turn into these little mod kits. Yeah, so we're unplugging that, unplugging this, yeah, and I mean, right now it's plugged in with a LiPo battery. I'll switch the data to internal, and I'll turn it back on. So, I mean, it doesn't have a cool boot up sequence, but this is what that's off again, and here it is turned on. Ding! Just kind of turns on. Let me zoom in again. And yeah, it's a zoomed in view. So, these brass bond wires, initially I just kind of wanted to put put them in there as they are, as like a nice, pretty structural piece that, I don't know, wasn't really functional but aesthetically looked cool. There aren't too many badges. Forgive me, I haven't really mentioned badges. If you're just coming into this stream and you don't know what the heck I'm talking about, yes, this is like a circuit board. It's electronics, but there's this whole scene of people that kind of surrounds DEF CON and other security conferences that have embraced the processes of using the processes of like making circuit boards, but like applying like really creative artistic ideas to it. And a lot of people associated with it post things under the Badge Life hashtag, or just like Badge Life is a word that you will hear in association with all these like cool blinking circuit boards. And yeah, so that's just like a little explanation. Oh yeah, and they're badges because like they are used as the badges that people wear around their necks at different security conferences. Like some conferences have official badges that are electronic, and you need them to be worn to like show that you've paid to get into the conference. But then all sorts of people make their own badges independently of the conferences, so there's tons of unofficial ones floating around now too. And that's like, I don't know, the group of people that I was inspired by to try and attempt this. And it's interesting because it has for sure pushed me further down the road of learning how to do anything with electronics than anything ever did previously. Like, I mean, I messed around with Arduinos and Raspberry Pis a bunch before, but never would have contemplated making my own circuit board, like a custom one. But it was neat to be exposed to the community that provides really good instruction, like Chris Gamble and Twinkle Twinkie, pardon me. Yeah, they both have like excellent videos, and the and not Exor guys, they have a couple streams that are just like really good as far as, I don't know, illustrating to, you know, anybody out there that they can, I don't know, kind of recreate some of these really cool artistic circuit boards with, I don't know, really easy to use tools for the most part. Like I did all this in KiCad with Inkscape to get the art taken care of, and I have a background using Photoshop a lot, so Inkscape was definitely different and a little frustrating at times, but it was nothing I couldn't learn. And KiCad, like that was, again, like, I think a lot of photo editing, it feels kind of familiar to anybody that's used a photo editor, but it isn't immediately apparent how you're supposed to use it whatsoever. But Chris Gamble's Getting to Blinky videos, they're really awesome, and they explain, I don't know, quite a bit about, well, like, I mean, just everything you need to know to get going. Speaking of Chris Gamble, I actually ordered this like add-on kit from him. This is not a camera. It's like a blinking security camera add-on kit for a badge. I still haven't put it together, but maybe I will stream building that someday soon. Anyhow, yeah, Inkscape, KiCad, tools I hadn't used before, but now I'm learning how to use them. Thanks to everybody that's taking the time to show us how to use them. So yeah, I don't know. Here's the Pixel badge. I turned it on. I've been talking about it for at least 20 minutes, and you've not seen anything that it does on its own, except this, just kind of this breathing, pulsing animation. So right now, I'll just kind of scroll through. Well, first, right off the bat, this is what it's going to do when it turns on, but I mean, I envision people wearing these at conferences, and they're going to want to customize them. They're going to like want to make them their own. That's what everybody does with the different badges that you have the ability to type your handle into. And everybody, like, well, not everybody, but a lot of people, you'll see them walking around with their handle being displayed on some sort of screen or an array of LEDs. Obviously, with this, you're not going to be able to type out any text, but I want to make it customizable to where you can represent whatever you want with whatever colors mean whatever to you. And it's interesting, on that note, I think it's going to be interesting to see what things can be communicated to one another only using 3 pixels that you can change the color of. But yeah, essentially all these bond wires, they're touch inputs, and if I hold it down, you can see the colors have changed a little bit. So you just hold down on one of the, I don't know how to explain this, sorry. The 3 bond wires that are leading up to the actual LEDs are the buttons, if you will, that control each one of those LEDs. So, yeah, I didn't mention this at all. These bond wires, they're touch inputs. So it's, yeah, you can touch it and it does stuff. That's part of why I ended up choosing the ESP32. Well, no, that's a lie. I had an ESP32 laying around, this one, the Hornbill dev board. And that is what I started building this project off of. Then I found out that you can use touch inputs on the ESP32, and then these bond wires turned from just being really cool looking things into actual functional buttons for the badge. So, with that explained, I'm going to pick this up. Sometimes it helps to hold the battery connector I found on other badges with touch inputs. Mine's no different. It works a little bit differently when it's plugged in via USB to a computer or some other power source, but when it's running off the LiPo, it seems like I have to kind of ground myself on the casing of the USB jack. But yeah, here, I'm holding it down, the animation stops, and you can kind of see that pixel all the way on the left. It's scrolling through different colors, slowly but surely. And yeah, so you can change each one of these. It's sort of slow. I mean, I haven't figured out the exact speed to do this, but it's also kind of weird. I'm not like a UI or UX designer, so I don't know how, I don't know how people are going to use it and what is going to feel right to people. But I kind of like that, just being able to hold the bond wire down and it changes the color. And then you let go and it continues to do the animation that it was doing. So that covers these 3 bond wires. Now the next 2 I want to talk about are this one here and this one up here. I don't really know how to name these or talk about them. It's going to be really confusing. I'll figure out how to document it someday. But these 2 are what go kind of left and right through the different animations that are on board. So the first 3 animations, I believe, pay attention to the custom colors that you've just set, and that's like something I'm going to continue working on, but for now I only have 3 built in, but and of course here. So this is like something kind of interesting happened on the very first time I tried to show you this. Due to poor programming, the brightness doesn't automatically stay at a certain state with each new animation that is switched to. It just kind of carries over from whatever brightness level it was at, and so that very first animation that is playing, I don't know, it dips down very low. So if you just so happen to switch the animation at that low point, the next animation will be invisible or barely visible, like this one isn't here. But just to illustrate some more features of the badge, I'll talk about these 2 down at the these 2 bond wires down at the very bottom real quick. Those 2 control the brightness. So in theory, there you go. That's full brightness probably, and then it dips down as I hold this one. So you can control the brightness. That's great. So like I was saying, we're on the second animation, and it's listening to the colors that you set earlier, the user-definable ones. And throughout any of these modes, you can just go through and change. And this one, it doesn't really pause, but you can see that first pixel all the way on the left. It's changing color as things are happening. But yeah, and then this is the next animation. It's just kind of bouncing back and forth, doing a Knight Rider-y kind of thing. And those are the only ones that listen to the user-definable colors. And then the rest of this is basically just like the NeoPixel strand test example from like the Adafruit NeoPixel library. And turn down the brightness there. So there you go. Yeah, but it's just solid colors. I'm switching through them. Eventually it'll get through to these guys, the theater chases. Let me turn up the brightness a little bit. Why isn't the brightness turning up? The brightness is capped in this mode. There's some cool RGB modes. Strobe epileptic RGB mode. Same, different rainbow mode. And now we're back to the custom colors. So that's all that it does really right now, but I mean, it's got an ESP32 in it, and I don't know, obviously that has Bluetooth and Wi-Fi, and I would like to use the Bluetooth. I've seen a lot of badges that kind of interact with one another when they're close by. That was a huge part of the DEF CON 27 badge, and same with like the Hack for Satan badges, and I don't know, many badges that have some sort of interactivity, and because this has a Bluetooth chip built in, that's something that I'm going to probably want to try and do, but that's, like, I don't know, something I've never done. I'm going to have to learn how to do it. But this is a great project for pushing me to learn how to do things. Speaking of, let me just turn it off, flip it over, show you the back. So, I mean, the ESP32 on here, well, I mean, that wasn't even that bad. I could hand solder that, but just talking about soldering and like building up my skills, I reflowed everything on this board, and this is the, I mean, second or third thing that I ever reflowed, and that like was I was pushed to do so by a conversation that Dr. Nopeside and Jiggle Billy from SetKC were having on Twitter, and I don't know what they were talking about exactly, but I said something about not being able to reflow or not knowing how, and somebody mentioned that, I mean, there's like no time like the present to learn how, and that's the truth. I mean, yeah, so I mean, it was within my means to grab a $40 hot air rework tool off of Amazon. It's like the cheapest one they make, and I think this SAO board was actually the first thing that I reflowed, and it wasn't, I mean, it was a lot easier than I expected it to be. These components aren't that hard, or they're not that small, so it wasn't that difficult. This one, however, I mean, for the most part, again, this wasn't all that difficult. There's just one little thing. Here, let me switch over to the micro scope. What? This CP, this guy, CP2102, it's a QFP, or QFN, sorry, I don't know my package names, but it was super difficult for me to solder. I had to reflow it twice, and kind of touch some stuff up by hand. It's kind of sloppy. But yeah, that was, I don't know if it's the way I'm applying the paste or what, but that was one of the more difficult things I've ever soldered. So, yeah. Yeah, but just talking about what's on the back of the board here real briefly before I kill this stream. This is the brains of the operation, the ESP32 Room 32D. I mean, the majority of this schematic was just copied directly from the Hornbill ESP32 dev board. They have the schematic up on GitHub, and it's all open source. And speaking of, like, this whole open source thing, open source hardware, I want to learn more about it because I see Arturo182 post things online, and he does a lot of open hardware, and it's just like, I mean, I feel like a lot of my views fall in line with like doing things in a kind of open source way, and that's something that I always plan on releasing the code and releasing the Gerbers and design files and all that, but I don't. I need to do more research learning about how to properly kind of market as open source hardware and provide all the correct information based on that. But yeah, so I want to do that because it's awesome, because like I was essentially able to look up all the bits and pieces of this board and copy it onto mine, and I could not believe it when I assembled it and it worked. I mean, I guess there is no good reason that it shouldn't have worked, but this is by far the most advanced kind of circuitry or electronics project I've ever worked on, and it was just beyond gratifying to have it turn on and work when I assembled it. And I mean, I had to reflow the ESP twice, and I also had to reflow the CP. This is CP2102. It's the USB to UART bridge, and like, I mean, yeah, it was mind-boggling. I didn't have the CP2102 going at first, and I just I used an external USB to UART chip and wired them up to the pins and programmed it that way. And that was huge in and of itself, because I mean, it was on and working, and I had flashed it with the program that I wrote. But then when I got the UART chip on board correctly reflowed, and I was able to plug it in through the USB port, it was just, I don't know, it was super cool. It was a very good feeling. So I'm just like very, very appreciative to everybody that's like, I don't know, anybody involved with any of the badge life stuff or just electronics in general, like Adafruit and SparkFun and all these people that I've been mentioning in the stream already, just kind of like showcasing that this stuff is available and an option for people, like especially hobbyists like me that don't, I don't know what I'm doing, but I'm learning a ton and having a good time while learning how to do this stuff. And I don't know, it's really cool. This was something that I always wanted to do when I was getting into college, and I actually just had like trouble finding electronics classes in the way that like I thought that they would be available, and then it was just something that I lost focus on. So I'm glad to be getting back into it through this. But yeah. Oh, I want to show you guys one more thing I just thought of. When you turn it on the back, there's some indicator LEDs. The red LED is the power LED. The green LED, it's wired up to the, I believe it's the enable pin on the ESP32, and it turns on when the ESP32 is up and running. Like it goes out when I hit the reset button. And I've also noticed that light wasn't lighting up when this was not reflowed correctly, and I think it's because this wasn't booting up or turning on fully. Not 100% sure. But then there's a boot button as well that gets it into bootloader mode. I copied this transistor circuit that is supposed to automatically enter the boot mode when you try to like upload a program from the Arduino IDE, and it's not working. And I saw one problem where I just physically did not connect two pins in the schematic, so it didn't happen on the board. And so I ran a bodge wire, and it got further along in the process, but it still wasn't working. So I need to kind of reevaluate what's going on with those transistors. I think that I may have messed up the connecting the bases in the collectors or whatever, confusing two of the two different parts of the transistor for the other. So I got to fix that. But luckily I still put in the buttons, so I'm still able to enter the boot mode really easily. But yeah, I got the power indicator, the green. That green guy for the ESP32, and then there's another LED down here that's a blue LED, and it turns on when I'm charging the battery, when it's plugged in via USB. And I just thought it was kind of fun that I did RGB for the status indicator lights. But just, I guess, a tour around the backside of the board also real quick before I go. We'll just start up here with the ESP32. It's the main brain. There's the JST PH input for the NeoPixel data. I have a SAO header. I actually haven't tested that yet to make sure it works, so I'll try soldering one on here soon. But that's for different DEF CON badge, the add-on badges that people make. Just like that one. Oh yeah, you can't see. Just like that one. There's lanyard holes up at the top. This one's awfully close to some of the pins. Specifically, I think it's ground and 3.3 volts that are right next to it. So if I use a metal hook for the badge lanyards, I'm scared that might short out. So I'm going to address that either with plastic hooks or modifying this design somehow. Or maybe some silicone right there. I don't know. But this lanyard hole is fine. This switch right here switches between internal and external data for the NeoPixels. Then down, you got a 19-pin, I believe, header, like single-pin header. Another one over here. That was like a huge thing I wanted to add on to this badge. After I saw a couple add-ons and badges come out that had all the data pins for whatever the microcontroller was broken out on it, I like got mad at myself for not doing that with any of my previous projects. Especially, like, I mean, it turns it from just like kind of a blinking circuit board thing into, in some ways, a little dev board that people can hack on and do cool things with. So, I don't know, I was really happy to add those two on. But then going down and around, we got the power switch, we got a LiPo battery plug. There's circuitry for both power regulation and the battery charger kind of on this side of the board. There's the boot switch and the reset switch, like I mentioned previously. Here's the NeoPixel data output. USB UART bridge, the crystal. This is the auto programming logic circuit that doesn't work right now. Then these kind of three grouped together resistors and capacitors are all part of the NeoPixel chain. These are things that I think that I could have omitted, but I mean that it's in the data sheet for the WS2812S, and I'm pretty sure that's like the same thing that's going on with the capacitor that's on every single section of a strip that you can cut apart. So I'm glad I put that on there and followed the correct instructions in the data sheet. And that's pretty much everything that's on the board, minus like the stuff that's not populated. All these silver pads up and down in the middle. These are all related to the touch, like the touchability of this board. In the ESP32 like hardware design guide, I followed or tried to follow its best practices as far as touch sensitive inputs. I did everything that it said, but part of what it said to do was put a capacitor, like a bypass capacitor, coming off of like your electrode to ground. And I don't, like, the capacitance value wasn't listed in the data sheet, and I couldn't really find it online. So I designed the circuit with a capacitor there, and then I put a jumper trace that I could cut if it didn't work. Because what ended up happening is when this was on a breadboard, I tried putting a capacitor in line like it says to in the data sheet, and it didn't work the way I expected to. It just kind of constantly showed that touch input as always being touched. And I messed with the threshold in the code, but it didn't really ever work out the way I expected to. So instead of actually populating all those capacitors and then having to cut the jumpers, I just didn't even put the capacitors on there. And so that's why everything's blank on the backside. Yeah. I guess, I don't know. I might take all that stuff away on the next version of the board. Down here you can see it says V2. This is the Pixel Badge 2, and this is the second iteration of this board. The first one, here, let me pull this aside. This is the first version of the board. This was the one that, like, I mean, this was just a test that I did for kind of to prove the artwork, that it would look okay with the black, what is it, the matte black solder mask. But also it was all about like me figuring out if I could solder these bond wires to the circuit board. And here's the back side of it. Here, I taped this on so that the wires would not fall off. But there's the back side of it. This is V2.1 of the board. I'm trying to label these things and get a little bit better about doing these things. But if you see these holes, they're tiny. I totally screwed up the custom hole size, or the custom footprint that I made in KiCad or KiCad. Yeah, it didn't work out. I think I made the pad size the correct diameter for one of the brass pipes to go through, but the actual drill part of it, I left it whatever the default setting is, I guess. I don't know. Just one more thing on the list of things that I've learned through, I don't know, through the process of making these circuit boards. I really have poor attention to detail, but it's making me slow down and double check things when I do this, because it costs a little bit of money. You're creating e-waste, which is this whole other thing that I've become aware of with the badge life scene and making circuit boards. But yeah, I'm really trying not to mess things up too bad. Or too many times, I guess. With these boards from my add-on, I think I got through 7 revisions before I landed on the final one, and I'm really happy that with this Pixel badge that I'm only on the 2nd version of the board, and it's it's not complete in my eyes, but it's I don't know, I'm impressed with myself with, I don't know, it's kind of finished feeling. It feels like a bit of a product, or it's comparable to some of the other badges that I've purchased in that it's got a brain, it's got blinky stuff, you plug it in via USB and it charges a battery. I don't know, it's got some unique features. I think people are gonna like it. So I don't know, that's that. Zooming out, shaking the camera, making you guys go crazy. Yeah, I don't know. I guess I'm going to wrap up the stream here. This was a little bit of an experiment. I think that, yeah, I think that, oh man, somebody's finally in here. Van Hammer's I see you. Yeah, I just wanted to test, I don't know, how streaming is going to work. And explaining things kind of, I don't know, more fully a little bit than just sporadic, spazzy 10-second clips that I upload to Twitter all the time. So here you go. Thanks for checking it out. I don't know. I'm going to build a badge on here maybe tomorrow and bug you guys some more. Thanks for watching.